Hello, everyone. My name is Tag Harris, and today I'll be presenting my research on the impact of chronic alcohol exposure on myelin ultrastructure in the brain. Myelin is a critical component of the vertebrae nervous system, ensheathing axons and accelerating action potential propagation. Disruption of myelin has significant implications for neural communication and overall brain function. In humans, chronic alcohol exposure is known to disrupt myelin gene and protein expression, reducing white matter integrity. This study aimed to explore how chronic intermittent ethanol, or CIE, exposure affects myelin ultrastructure in three specific white matter tracts in the mouse brain. To investigate this, we used a CIE vapor inhalation model with two male mice. One mouse underwent 6 non-consecutive weeks of CI exposure, involving 4 daily cycles of 16-hour ethanol intoxication, followed by 8-hour withdrawal. Each 16-hour exposure period was primed with intraperitoneal ethanol and pyrazole injections to standardize blood alcohol levels. The control mouse, exposed to air, received pyrazole only. 5 days after the final withdrawal, the mice were perfused and immersed in fixative for 3 weeks. Brain punches from all of the areas in the brain were processed for electron microscopy at 5,300 times magnification. We captured 15 non-overlapping fields of view per tract and analyzed axons greater than zero point 0.3 micrometers in diameter. Myelin pathologies, such as splitting, uncompacted myelin, redundant myelin, and myelin whorls, were quantified and normalized to the total number of myelinated axons using Fiji software. During ethanol exposure, the CIE mouse maintained an average blood alcohol level of 199 plus or minus 15 milligrams per deciliter. In terms of myelin pathologies, redundant myelin was consistently low in both mice. Myelin whorls were extremely rare, with just one of them having the pathology. Splitting myelin and uncompacted myelin, however, were more prevalent in the CIE mouse. Notably, splitting myelin showed the most significant increase, particularly in the anterior commissure. In conclusion, these findings demonstrate that chronic intermittent ethanol exposure disrupts myelin ultrastructure, with splitting and uncompacted myelin being the most affected pathologies. The observed effects could stem from intoxication, withdrawal, or a combination of both. While this study is limited by its small sample size, it highlights the impact of ethanol exposure on white matter integrity. Future research is needed to validate these findings across larger cohorts, including both sexes, and explore additional brain regions. Ultimately, this will help clarify the mechanisms underlying ethanol-induced myelin damage and its implications for neural function. Thank you for your time and attention. I'm happy to answer any questions or discuss this research further. Thanks.